Alrighty. Hey, last time we were looking at how to calculate oxidation numbers. And again, oxidation numbers, charge, same thing, right? It's that number that's up in the upper right-hand corner that's like a +2 or +3 or -2 or -1 or whatever it may be. Well, we were looking at how to calculate charges for like those transition metals, like Fe, that it could be a +2 or a +3. And so if we had like a compound of Fe2O3, how do we find out what the charge of oxygen is, and how do we find out what the charge of iron is? And in all of the compounds that we've looked at so far, the charge of the positive, the total charge from the positives plus the total charge from the negatives adds up to 0. Well, today we're going to look at when the charge doesn't add up to 0, and that's really when we're looking at these polyatomic ions, okay? So we're going to learn how to calculate those charges when we're dealing with something that doesn't add up to 0. Now, because in these polyatomic ions there's no metals, we don't know for sure some of our charges as much. Well, that didn't make a lick of sense, but just look here, okay? We really know two things when we're dealing with these compounds. We know that hydrogen is going to be a +1, and we know that oxygen is going to be a -2. We're not looking at group 1 metals, group 2 metals, because we don't have any clue of dealing with those because they're not found in polyatomic ions, okay? So hydrogen is +1, oxygen is a -2. But again, it's not going to add up to 0, it's going to add up to something different. So how do we know what it's going to add up to? Well, if you look here at hydroxide, hydroxide is OH -1. And so the -1 right here means that the charges are going to add up to -1. Now, thankfully for this is a pretty easy one because we know that oxygen is a -2 always, and we know that hydrogen is a +1. And so sure enough, we have 1 oxygen times the -2 plus your 1 hydrogen times your +1. And we said that they're going to add up, here's the key, to -1. And sure enough, -2 plus 1 is equal to -1. Alright, so in that one we didn't even have to find any of the charges. Let's look at the next one. This one's a little bit harder. Again, the whole thing is going to add up to a -1 here. Now, do we know the chlorine's charge, or do we know oxygen's charge? Well, we said we only know that hydrogen is +1, oxygen is a -2. So we do know the oxygen. And so the oxygen is -2 here. Now, what we need to do then is we take our chlorine, and if you remember right, for our unknown, we just put in X. So I have 1 chlorine times X plus the number of oxygens, which in this case is 3 right there. 3 times -2 is going to add up then to a -1. Now that gives me an equation then of X minus 6, because 3 times -2 is -6, is equal to a -1. Well, how do we get the X all by itself? Add 6. Add 6. -1 plus 6 will give us X is equal to a +5. So in this case, we have a +5 for our chlorine. Now, to go back and check yourself, do this. Put your 5 up here, -2 on above your oxygen. Look at this, 5. Okay, well 5 minus 6, again, is equal to a -1. So that ends up working out, okay? We have one more negative than we have positive. And so the overall charge is a -1. Now let's look at chlorite. Chlorite is ClO2 -1. And so again, it's still going to add up to a -1. But do we know the chlorine or the oxygen? Well, again, we know our oxygen is a -2, okay? So again, I have 1 times x, just put x, plus we have 2 times the negative 2 for our oxygen is equal to negative 1. So that means x minus 4 is equal to negative 1. 2 times negative 2 is a minus 4, okay? So to get x by itself, add 4. Add 4, x is equal to a positive 3. So in this case, in chlorite, the chlorine has a positive 3 instead. So again, chlorine is a positive 3, oxygen's negative 2. 3 minus the 4 would give you an overall charge of negative 1. Hopefully you're starting to kind of see the pattern here. Let's do sulfate, okay? With sulfate, I've got S and O. O again is a negative 2. And let's see if we can actually do a little more of a shorthand here, okay? Let's see. From these, I get then that x minus 8 is equal to, again, that's the negative 2. So, add 8, x, negative 2 plus 8 should be a positive 6. X is a positive 6 for sulfur. Okay, sulfite. Let's see how things are different here. I've got, again, oxygen's a negative 2, and it's going to add up to a negative 2 once more. But here's something that's a little bit different. Yes, my oxygen is there, but I have x from my sulfur minus, okay, negative 2 times 3 would give us minus 6 is equal to negative 2. Add 6, so we should get x is equal to a positive 4. So the sulfur is a positive 4. Notice again, 4 minus the 6 here gives you a negative 2. So that's how we go through and we find out the charge of the ones that you don't know for your oxidation numbers when you're dealing with a polyatomic ion.